Hi, I hope you are enjoying this video lecture series of IC engine and gas turbine. If you like this video series, then give thumbs up. If you have any doubt regarding any concept, please let me know through the comment section. And to watch more video like this, please subscribe my channel. Thank you. Welcome to the video lectures of IC engine and gas turbine. In this particular video, we will be demonstrating a cut section model of a two-stroke petrol engine. You can see this is a cut section model of a two-stroke petrol engine. And let me first introduce the different components that is generally associated with this cut section model. You can see this is the exhaust port through which the exhaust gases or the combustion products is generally driven out from the engine cylinder to the atmosphere, and below this exhaust port there is another port which is generally called the intake port. Okay, what is the purpose of intake port? Intake port generally connects the carburetor with the crankcase. In case of the two-stroke engine, the intake port is generally placed in between the carburetor and the crankcase. That means through this intake port, the air fuel mixture from the carburetor is generally entering into the crankcase. Try to remember, in case of four-stroke engine, we have seen that the intake manifold, through the intake manifold, the air fuel mixture is entering from the carburetor to the engine cylinder. But in case of two-stroke engine, we can see the intake port is generally connects the carburetor with the crankcase. That means the air fuel mixture from the carburetor is entering to the crankcase, not in the engine cylinder directly, and then this air fuel mixture is generally transferred to the engine cylinder by another port that will be generally discussed quite later. Okay, now you can see this is the carburetor which is generally placed at the end of the intake port, and this is the crankcase. Okay, where the crank is generally placed. The crank is placed, and in which the crank is generally rotating. And you can see this is there is another port which is generally this port is generally called the transfer port. What is the purpose of the transfer port? Transfer port is generally used to transfer the air fuel mixture that is drawn by the inlet port or the intake port, and this air fuel mixture of the crankcase is generally transferred through this transfer port to the engine cylinder. Okay, and thus the air fuel mixture in the crankcase is generally going to the engine cylinder. Okay, that is the purpose of the transfer port. So we have generally discussed the three ports are there. One is the exhaust port, this is the exhaust port, this is the intake port or the inlet port which generally delivers the air fuel mixture to the crankcase, and from the crankcase this air fuel mixture is generally transferred to the engine cylinder through the transfer port. And in case of four-stroke engine, we have seen there are two valves. One is the intake valve, another is the exhaust valve. But in this case, you will never find any valves. So question arises, how these ports are generally controlled, the opening and the closing of the ports generally how it is controlled. Okay, and that is generally controlled by the movement of the piston. You can see this is the piston, and if the piston is when the piston is moving from the top dead center to bottom dead center, then we can see this exhaust port and the transfer port is generally closed in this situation, and the intake port is generally open. Okay, and when it is generally at bottom dead center, then we will find the intake port is closed and the exhaust port and the transfer port is open, and this is how the opening and the closing of these ports are generally happening inside a two-stroke engine. Okay, now this is the piston which generally reciprocates within the engine cylinder, and this is the engine cylinder. You can see this is the engine cylinder, this hole is the engine block, this is the cylinder head. Okay, and this piston is generally connected with the crank crankshaft with the help of the connecting rod. Okay, what is the purpose of connecting rod? We have discussed several times. The purpose of the connecting rod is to transfer the reciprocating movement. This is the reciprocating movement. You can see the up down movement of the piston, and this reciprocating movement is generally transferred into the rotational movement of the crankshaft. Now you can see at the upper section there is the reciprocating movement of the piston, and the lower section in the crankcase you can see that reciprocating movement is generally transferred into the rotational movement, and that is generally done by this connecting rod. This red color rod is generally called the connecting rod. And since this is the cut section model of a SI engine, then we know for the combustion process, in case of SI engine or the spark ignition engine, a spark plug is generally used to ignite the air fuel mixture. That's why this is generally spark plug. Now you can find a special geometrical configuration that is generally constructed on the piston head, which we have not seen in case of generally 4-stroke engine. Okay, and this generally geometrical configuration or the geometrical construction is generally done for a process which is called the scavenging process, and this section is generally called the deflector. Okay, what is the purpose of this deflector? We will be discussing that also. Now we will see how 2-stroke engine generally works. Okay, that means there are 4 processes inside a engine. We have already discussed that. That's generally these are the intake process, compression process, expansion process, and the exhaust process, and that four processes are generally taking place inside and 2-stroke engine also. Okay, now we will see how these processes are generally taking place inside a 2-stroke engine and why it is called the 2-stroke. Okay, and what is the basic difference between this 2-stroke engine and the 4-stroke engine. Now if we consider the piston is at the top dead center, we have already discussed the two restricted area inside the engine cylinder. One is the top dead center, the uppermost area beyond which piston cannot move, and the bottommost area beyond which the piston cannot move. If we consider the piston is moving from the top dead center to the bottom dead center, then we will find what we will find. Now if we reciprocate the piston from the top dead center to the bottom dead center, then we will find the exhaust valve is exhaust port is generally open first, and then the transfer port is open. When the exhaust port is open, then the exhaust gas or the combustion product is generally driven out from the engine cylinder to the atmosphere, and after some time the transfer port is open. That means the intake process from the crankcase to the engine cylinder is taking place. So we can say at one stroke, when the piston is moving from the top dead center to bottom dead center, then there are two processes. One is the exhaust process and another one is the intake process to the engine cylinder, and thus in one stroke two processes are generally taking place in case of the 2-stroke engine. And when the piston is moving from bottom dead center to the top dead center, then we will see the first transfer port is generally closed, then the exhaust port is closed. First the transfer port is closed and then the exhaust port is closed, and when the piston is at the top dead center, then we will see the both port, the exhaust port and the transfer port, both ports are closed, but the intake port or the inlet port, that is generally open. This inlet port is open. That means the air fuel mixture from this carburetor is entering to the crankcase through this process, and as well as the piston is compressing the air fuel mixture which have been taken into the engine cylinder through the transfer port. Okay, so in this case, when the piston is moving from the bottom dead center to top dead center, then there are also two processes. One process is the compression process and another process, that is the intake process, and as well as the combustion of the air fuel mixture is generally taking place, and that's why due to the combustion of the air fuel mixture or the burning process, an axial thrust will be generally generated on the piston head, and thus the piston is generally moves from the top dead center to bottom dead center. So when the piston is moving from the top dead center or bottom dead center, there are two processes. One is the intake process, intake to the crankcase to the engine cylinder, and the exhaust process through which the combustion product or the product of the burning processes is generally going out from the engine cylinder. Okay, and when the piston is moving from bottom dead center to top dead center, there are also two processes. One is the compression process and another one is the expansion process, and as well as the intake process is also happening to the crankcase, and that means through the intake port or the inlet port, the air fuel mixtures from the carburetor is generally entering into the crankcase, and that's how the two processes are generally taking place in a stroke in case of two-stroke engine, and that's why we are generally getting one power stroke for one revolution of the crankshaft. Okay, in case of four-stroke engine, we have seen there are there are two revolution of the crankshaft for one power stroke, but in case of two-stroke engine, we can find there is one revolution of the crankshaft for one power stroke. Okay, and during the power stroke, which I am generally using to rotate the crankshaft or reciprocate this piston, this is generally called the flywheel. The excessive energy is generally stored in the flywheel in case of two-stroke engine, also in case of four-stroke engine, but the lighter the flywheel which is used in case of a two-stroke engine, that is generally lighter than the four-stroke engine. Okay, this is the whole working principle of a two-stroke petrol engine.